The heavenly visitor has made some meaningful difference as cosmologists have found our solar system was once visited by an unfamiliar star that significantly changed the trajectories of certain comets and ice fragments. Although the unsettling star had a very low mass, it was still enough to stir up the objects in the Oort cloud. But what led to this shimmering intruder entering our planetary system in the first place? Where is the star today, and what lessons can we gain from this cosmic encounter? Although the launch of the two Voyager probes dates back over 45 years, these spacecraft have continued their brave journey through the vast expanse of space as the most remote stations of humankind. The identical sister probes have now ventured into interstellar space, putting billions of kilometers between themselves and the Sun. Voyager 1 is currently an impressive 16,466 astronomical units, AU, away from our host star. With 1 AU corresponding to the mean distance between the Sun and Earth, around 150 million kilometers, this is about 2,463 billion kilometers. Voyager 2, on the other hand, is even closer to the Sun. The distance between the probe and our brilliant life-giver is only 13,761 Australian dollars, or 20.59 billion kilometers. If you had looked up at the night sky around 70,000 years ago, you wouldn't have seen the Voyager probes, but you might have noticed a striking red in the atmosphere. This was not because there was no light pollution in those days, nor because the night sky looked more majestic than it does today, but because of a celestial visitor that had slipped into our home system. Strictly speaking, the Stone Age star visit arrived as a double feature. A red dwarf, likely accompanied by a brown dwarf, was given the rather awkward scientific name WISE J0723-846, but it's generally known as Scholz's star. The star system owes its simpler name to its discoverer, Ralph Dieter Scholz, who first identified the objects in 2013. Since red dwarfs are known to experience violent flares from time to time, our ancestors and Neanderthals might have wondered at a reddish point of light in the sky millennia ago. However, the dwarf's low mass, just 0.15 solar masses, initially made it seem unlikely that this celestial lightweight could have a significant impact on the celestial bodies of our solar system. But there were some anomalies that made scientists suspicious. Although Scholz's star is currently around 22 light-years from Earth, it appears to be barely moving, despite its relative proximity to us. Essentially, there are two ways to explain this phenomenon: either the star is heading toward the solar system or it is moving away from it. To determine which is the case, scientists at the University of Rochester examined the star's trajectory using spectral analysis. Surprisingly, the calculations clearly indicated that Scholz's star is currently on its farewell tour through the solar system. However, this also meant that it must have been much closer to the Sun in the past. But how close, exactly? To find the answer, astronomers used trajectory data and speed to model the star's path and traveled back in time. This virtual journey revealed that approximately 70,000 years ago, Scholz's star passed through the Oort cloud in 98% of 10,000 different orbital simulations. To briefly recap, the Oort cloud is a hypothetical shell-shaped region in the outer reaches of the solar system thought to be the origin of long-period comets. While its existence has not been confirmed, scientists believe the Oort cloud extends up to 100,000 Australian dollars. Given Scholz's star's small mass, scientists initially assumed it didn't cause any major disturbances during its passage through the distant collection of icy objects. But they may have been mistaken. From the beginning, scientists suspected that there could be no other known star that had come as close to our solar system as this one. But in astronomical terms, close still means 52,000 Australian dollars, or 0.8 light-years. The nearest star to the Sun, Proxima Centauri, is located at 4 light-years away, 5 times farther than this. Despite its low mass, the theory that long-period comets were significantly influenced by close stellar encounters is not new. However, until recently, there was no known star that met the necessary galactic conditions to validate this theory. Still, not all researchers were convinced that the passage of Scholz's star had no impact on its surroundings. Among the skeptics was Carlos de la Fuente Marcos from the Complutense University of Madrid. He and his colleagues studied the orbits of nearly 340 objects that follow highly eccentric paths through the solar system. In their simulations, they pinpointed the directions from which these eccentric objects appeared to originate. They expected that the positions of the objects would be evenly distributed across the sky since the Oort cloud surrounds the solar system like a closed shell. However, their findings revealed a different picture. The scientists observed a significant clustering in one particular direction. Most of the sampled objects' paths pointed toward the constellation Gemini. This suggested that the origin of these objects lies in the region of the Oort cloud that Scholz's star came closest to 70,000 years ago. The astronomers concluded that this correlation is unlikely to be a coincidence. The timing and location of these orbital disturbances align so well with Scholz's star's passage that they strongly suggest a direct connection. Following the scientists' calculations, the star might have come even closer to the Sun than initially thought, possibly just 0.6 light-years. At this reduced distance, it could have shot some ice fragments out of their original orbits. So, what does the situation look like today? Scholz's star has now moved back to around 22 light-years from the Sun, and it may be some time before another star follows a similar trajectory. Experts estimate that a star passes within 52,000 Australian dollars of the Sun approximately once every 9 million years. However, there is one star that is in something of a hurry. Known as Gliese 710, this rogue star is on a direct course for the solar system. Unlike Scholz's star, scientists agree from the outset that this stellar visitor will cause considerable disruption in the Oort cloud. Although the star has a mass of only 0.6 solar masses and about 1.3 million years, it's expected to come as close as 1.1 light-years to the Sun. This proximity could stir up the objects in the Oort cloud to the extent that a full-blown comet shower could enter the inner solar system. This also increases the risk of a comet impact on Earth by at least 5%. Our distant descendants can only hope that none of these objects will pose a catastrophic threat to Earth. But there's still a long way to go until 1.3 million years from now, and NASA has already demonstrated with its DART mission how the trajectory of a celestial body can be altered with a targeted impact. And now, here's how you can modify the videos on your homepage. Click the subscribe button, give us a thumbs up, and subscribe to never miss another post from us. See you soon.